Today we're going to do 8M7 Lesson 2, Square Roots. We're going to focus today on two questions. One, what is a square root? We've talked about it prior, but we're just going to go over the definition one more time. And the second thing we're going to do is we're going to learn how to estimate square roots. We did a little bit of that in Lesson 1, but we're going to show you two methods today. I'm also going to use a new tool that I haven't used before, which is going to be a document camera. We'll see how that works on this video. Let's get going with our scratch pad. Here we go. All right, lesson 2, square roots. So what is a square root? We asked the question, what is a square root? A square root asks this question: what number times itself equals the number under the radical or the square root sign? So when we see this, what does it mean? It means what number multiplied by itself is 49? That's what this means. And so the square root of 49 must equal 7, because 7 times 7 is 49. Now I want to make out one other key point. It says it's really what positive number times itself equals 49, because we do know that -7 times -7 equals 49. However, when we use this square root sign, we mean the positive number, because there's two numbers that multiply by itself will give you a positive number, but we don't want these negative numbers when we use this sign. If we wanted the negative version, we would say the square root, then negative the square root of 49, and that equals -7. Okay, that's what we would say. But we're not going to worry about that. We're just going to say we're looking for positive numbers, unless I specifically call it out or the book explicitly calls that out. We're just worrying about the positive versions. Okay, so that's point number 1. And now we're going to make 2 points on this slide. The second point is this. Let's draw, and this is going to help us with our approximations as we go forward in further slides. So we do know, let's just start off, that we know that 0 squared is 0, because 0 times 0 is 0. 1 squared is 1. 2 squared is 4. And then 3 squared is 9. So similarly, or we could write it a different way. We could say the square root of 9 is 3. The square root of, well, let's do it differently. Let's start with the square root of 0 is 0. That's this line. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. Right? Because that's just kind of undoing these lines here. So this is x and x squared, and this is, like x and then the square root of x. So the square root kind of undoes the squaring of a number, because we could say 2 squared is 4, and the square root of 4 then is 2. 3 squared is 9, and the square root of 9 is 3. Okay, now let's move on and ask this question then. Where would you place on this number line these numbers? The square root of 2 and the square root of 3, the square root of 5, square root of 7, and the square root of 10. Well, they have to fit in order on this line here. So if I said, well, where's the square root of 2? The square root of 2, well, it wouldn't fit here, because the square root of 1 is 1. So if 1 times 1 is 1, then there's not a number smaller than 1 times itself that will equal 2. So the square root of 2 must go over here. Likewise, the square root of 3 must go here, less than the square root of 4. The square root of 5, the square root of 6, the square root of 7, and the square root of 8 would go here. And so the square root of 10 would fit here. I hope this makes sense, because if 2 times 2 is 4, then a number times itself to equal 5 has to be greater than 2. It has to be like 2 times 2.2 has got to be close to 5. We can't find a number less than 2 times itself that'll be close to 5. That number's got to be between 2 and 3. And this works all the way up to infinity. We're gonna work some more examples that really drill down on this principle in the next couple slides. Okay, so square root of 2 must fit somewhere around here. It's not going to be exactly 1.33, and this is not going to be exactly 1.66, but it's going to be about these numbers. It's going to be kind of close, or at least it's a good starting point. They don't evenly fit between square root of 1 and square root of 4. They don't exist exactly between 1 and 2. These are not equal jumps, but they're kind of close. It's a good estimate. Okay, so let's go forward to the question of the day. This is really what we're going to focus on in this lesson, and what your homework will focus on. It's this concept of finding the closest integer to a square root, or an exact number, if it's an exact number. Like if you had the square root of 9, the answer is 3. It's not, square root of 9 isn't close to 3, it is exactly 3. But for the most part on your homework, most of the problems are going to be close to, or they're going to be questions where the answer is close to a number, an integer number, but not exactly. So there's 2 ways that we can find the closest integer to a square root. And I'm going to tell them to you right now. They're kind of similar, but a little slightly different. So to find the the square root of a number, you find the perfect square on either side of the square root. So remember, perfect squares are these numbers: 1, 9, 16. These are perfect, what they call perfect squares. And they are perfect squares. These are numbers whose square roots are integers. Those are perfect squares. 25, 36. You know these. You learn these in maybe 2nd, 3rd, 4th grade. I don't know. 64, 81, 100. Those are perfect squares, and they keep going. There's an infinite number of perfect squares. So what you're going to do is you're going to find the perfect square on either side of a number, and then you're going to find which number this is closest to. That's method 1. So in method 1, we'd say, well, the square root of 68 is between which one? 64 and 81. So we would say, well, 64, 68, and the square root of 81. Well, we know the square root of 64 is 8, and we know that the square root of 81 is 9. So the square root of 68 must be between 8 and 9. So that's our starting point. But the square root of 68 is closer to 64. It's closer. And this is further. So the square root of 68 is closer. So the square root of 68 is closer to 8, because 68 is closer to 64 than 81. So 8 is our answer. Now I'm going to pick a huge caveat, and there's some teachers who might be watching this video and say, whoa, wait, you can't, it's not, this is not perfect, and they would be right. When the number is in the middle or close to the middle of the two perfect squares, this method does not work. So if this number was the square root of 72, and that's 8 away from 64 and 9 away from 81, you could not say that the square root of 72 is closer to 8. You can't say that. Or similarly, if square root is 73, if it's close to the middle, you can't use this method. So because 68 is only 4 away from 64, and it is 13 away from 81, that's a big difference. So you can say that square root of 68 is closer to 8. So now let's use a different method. And this one is more perfect. Okay, and this one's going to be the calculator method. So in this case, we still are going to say, well, the square root of 64 and the square root of 81 are my bounding numbers. 8, and this is 9, and then we got to figure out the square root of 68. So what I'm going to do on my calculator, I'm not going to use my square root button. So if you can use the square root button, this is an easy thing, but we're going to do this without using a square root button. So no square root button. Don't use it. So what we're going to do is we're going to try 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7. And we're going to see what gets close to 68, and then we're going to give it a try. So let's just do this. I just want to test this out. So let's just go, and we're going to try this other screen for a second. This is just an experiment. I'm just having fun. Maybe you'll enjoy it too. So we're going to use. So let's look at my. Check this out. So now we're on my calculator. This is kind of fun. So we're going to try some numbers. So we're trying to find the number that's close to, and I'll put it over here. Close to, remember, we said the square root of 64, square root of 81, and then in the middle is the square root of 68. So we're going to try 8.1, 8.2, 8.3, 8.4, 8.5, and we're going to keep going, and we're going to see which one's close to the square root of 68. So let's turn our calculator on, and we're going to say, well, 8.1 is equal to, 8.1 times 8.1 equals 65. 8.2 times 8.2 is about 67. 8.3 times 8.3 is about, notice I'm going to round, is about 69. Well, I've just found two numbers, 8.2 and 8.3, that are on either side of my 68, square root of 68. So I know that the square root of 68 is between 8.2, square root of 68 must be between 8.2 and 8.3. So that means that the square root of 68 has to be closer to 8 than 9. So because square root of 68 is between 8.2 and 8.3, it is closer to 8 than 9. So 8 is my answer. Okay, hopefully that was fun for you, using a different technology for a little bit of my presentation. This might be something I decide to use more in the future as well. But let's get back over to our comfort zone here, where we said it's now between 8.2. 8.2, remember, was 67, and 8.3 was 69 about. And so we know that 8 is our answer, which is the same as we got over here, fortunately. So let's just lay down a happy cat, a happy cow. What are we doing? How come it switches over to that cow from time to time? I do not know. Let's just go back to happy cat. There's my comfort zone, happy cat. Okay, now what you're going to do on these next 2 slides is, this is homework help. So I want you to use a number line to find the closest integer to the following square roots. You don't necessarily need to use a number line. You can just, you can also just find the bounding perfect squares. That's what we did. What we did on the last slide. Now, as a hint, I'm going to tell you, if you didn't know, the square root of 169 is 13 and the square root of 196 is 14. I will give you that hint right here. And let's not do this number, by the way. Let's do, I want to, sorry, this number should be, let's make this number a little bit more obvious. Let's make this number 191. Okay, so let's go through and do these 8. So I want you to pause plus try these guys, and we'll do our answers in green. Okay, I assume you're back. So let's look at these square roots here. Well, on the square root of 7, we're going to find our bounding numbers. So our bounding numbers are the square root of 4 and the square root of 9. Let's just go ahead and write those down over here. These will help you out as we do these problems. If I just write them all down, it helps me out. Okay, so these are our perfect squares. And so I know square root of 7 must be between 4 and 9. Well, if I put 7 between here, it's closer to 9. So this is 3 away, this is 2 away. Now, even though that's close, it's closer to 9, and if the only way we can do this is to use a number line, we're going to have to then guess that it's closer to square root of 9. And so the answer is closer to 3. So we're going to guess 3. Now, normally, because this is a little bit closer, I might go back and use that other method, using the calculator. But again, if I have to use the number line, I'm going to guess closer to 3. So let's do 77. Well, 77, let's see, it's between these guys, square root of 64, the square root of 77, the square root of 81. Well, this difference here is 13, and this difference here is 4. So I'm going to go with square root of 81, and I'm going to say closer to 9. That's my estimate. Square root of 10, well, let's see, it's between square root of 9, square root of 10, and the square root of 16. Well, here we have a 1 difference, here we have a 6 difference, so it's closer to the square root of 9, so we're going to say closer to 3. 105. Uh-oh, we don't have another number up here. Well, it's greater than 100, so let's put 100 here. 105. So what's this? This is square root of 100 is 10, so I need to figure out what 11 squared is. Well, that's 121. So here we have a difference of 5, and here we have a difference of 16. So I'm going to say closer to 10. And 191, let's see. Well, I'm going to go over here and use my hint. And I say, well, 169, that's 13. And then 14 is the square root of 196. 191, this is 5. And this is, I don't know, see 70, this is 22. So it's closer to 14. Closer to square root of 196. So it's closer to 14. So that's approximations using just which one is finding the closer perfect square and then using that as our estimate, which is usually pretty good. Now let's go and let's use our calculator version. I'm only going to ask you to use 2 here. Well, let's see. So I know that this is between the square root of 25 and the square root of 36. So I know it's between 5 and 6. So let's do 5.1, 5.2, 5.3, 5.4. Let's see if that's enough. So 5.1 times 5.1 is 26. 5.2 times 5.2 is about 27. 5.3 times 5.3 is about 28. And then 5.4 times 5.4 is 29. So this is 29.16. So square root of 29, so the square root of 29 is between here and here. 29 is between here, so the square root of 29 is between here and here. So if the square root of 29 is between 5.3 and 5.4, then we know that our answer is closer to 5. We know it's between 5.3 and 5.4 specifically, but 5 is our closest integer. Now let's do the square root of 81. Well, that's between the square root of 81 and the square root of 100. So that's between 9 and 10. So square root of 87 is between 9 and 10. So let's try 9.1, 9.2, 9.3, 9.4. So let's do those numbers. 9.1 squared is 82.81. 9.2 squared is 84.86. 9.3 squared is 86.49. And 9.4 squared is 88.36. Well, here's our 87. Our 87 is between here and here. So the square root of 87 is between 9.3 and 9.4. So the square root of 87 is closer to 9 than 10. All right. So hopefully this is making sense. And here's happy cats for you solving those two problems. Now the problem with the square root of 88 is that 888 is I don't know what two integers are on either side of 888. So, well, let's see. I know, let me try some numbers. Let's see. Let's find the two closest integers first. So let's try 25. I know 25 it might be kind of close. So square root of 25 squared is 625. Well, Let's keep going. Let's try, how about 28 squared? We're just looking right now. This is 784. We're getting close. Let's try 30 squared. Well, 30 squared is 900. So we have a number bigger than 888. So let's see, 29 squared is what? 841. So 888, the square root of 888 fits between which two numbers? Well, 888 is bigger than 625. It's bigger than 724. It's bigger than 821, but it's less than 800. So let's put that 888 right here. And so the square root of 888 is between 29 squared and 30 squared. And it actually looks like it's a little bit, 888 is closer to 900 than 841. So let's try, so we would typically try 29.1 and 29.2, but I see that 888 is closer to 900. So let's try 29.5, 29.6, 29.7, 29.8. Let's see if we can find the one that's closer. I don't want to try this one first because I know that that's going to be a lot less. 888, again, closer to 900. So let's try 29.6 first. 29.6 squared is 800, and this is 876.16. So we know it's bigger than 29.6. So we know it's actually going to be closer to 30 than 29 already. But let's see if we can get a good decimal approximation. So let's try 29.7 squared. This is 882.09. And then we got 29.8 squared. Oh, wow, this is 888.04. So we have our two bounding numbers, 882 and 888.04. So 888 is between these two numbers. So the square root of 888 has to be between 29.7. So the square root of 888 is between the square root of is between 29.8 and 29.7. So it's closer to 30 than 29, right? Because 29.7 and a number between 29.7 and 29.8 has to be closer to 30 than 29. And that deserves our final happy cat. Nice work. And we are going to cut back to one final picture of me with my hair a little messed up. And we will say next time, hopefully this was straightforward. We'll do next time, 8 and 7, lesson 3. Love having you with me. Love teaching math. Tell your friends if this is helpful to you. Tell your teacher if this is helpful. Tell your friends in class if this is helpful on your homework. If it's helpful with explanation, great. Tell your friends. If there's something that you'd like me to do better or different, give me a comment on YouTube. I have answered questions that students have asked me individually on YouTube. I can put up another video. I can answer the questions in text. Whatever I think or what you think you need, I'm here to help you out. Over and out. Talk to you next time.